Joules law of heating gives the amount of heat produced by any heating device. So the energy provided to any circuit, which is a purely resistive circuit or basically heating device, both are one and the same. This entire energy in an ideal scenario gets converted to heat. The amount of heat that is generated by this is given by Joules law of heating, which tells the heat produced by this particular device depends on the voltage it's across and the current flowing through it and the time that the device is switched on. That makes sense, right? More the voltage, more the current, and more the time you switch on a device, more heat it will generate. So there is a way of remembering this, which is makes it easy, simple. Hit Venus. So you can make use of this to remember this particular formula. H is equal to I into T into V. As simple as that. Now, the derivation. So, see, heat is a form of energy. And we can equate it to work also. So, we know that work is given by rate of, so not rate of power into time. Right? Power is rate of doing work. So, work is equal to power into time. This is your expression 1. But power is nothing but again work by time, but work is V into Q by T. Is it not? So Q by T is nothing but your current, right? I is equal to Q by T. And so if I substitute this power, which is V into I in equation 1, so sub 2 in 1, we're going to get H is equal to V into I into T. This is my expression that's required over here. That's it. Okay, again, you can use Ohm's law and have different expressions. So V is equal to I into R. So we have H is equal to I square RT. And the expression for I is V by R. So H is again equal to V square by R into T. Depending on the scenario, you guys can use any one of this. Please don't memorize this. I'm just showing it to you guys. Don't think too much about remembering this. It's of no use. If you remember this, you can derive at any point of time. Okay, so end of it. If I had to put it across in form of words, Joule's law of heating implies that heat produced in a resistor is directly proportional to the square of the current for a given resistor, directly proportional to the resistance of a given current, and directly proportional to the time for which the current flows through the resistor. That is, they've used this particular formula to talk about Joule's law of heating, that it's directly proportional to the square of the current, and it's directly proportional to the resistance and the time that it's switched on. Okay, so you can make a note of all of it. So now you can pause.